Hi everyone, so in this video I'm going to go over the quadratic formula, which is a Algebra 1 topic, and we're just going to make it a little bit more advanced with our Algebra 2 facts. The only way that this is going to get harder is with simplifying the radicals and having imaginary numbers, and you'll see that happen a few times in this lesson, and that's really the craziness, and everything else should be just like Algebra 1. The do now just asks you to find the solutions to the equation, so why don't you try to find the solutions, pause the video, and then unpause it. So I hope you did in box method because that would be too much work. All you have to do is factor this. So you just have to factor each piece. So do AM here and AM there. So I'm going to do x minus 3 and x minus 3 and then x minus 5 and x plus 1. So I can get the factors of this. Actually, this should be we want to get a positive 4, so it should be a minus 5 and a positive 1. Okay, this gets me, I don't know what my deal is. This should be a minus 1. I said it out loud, I think. Oh well, moving on. This will give you x equals 3, x equals 1, x equals 5, and x equals negative 1 as our answers. But now what happens if it does not factor nicely? And that's where the quadratic formula comes into play. The quadratic formula does not need to be memorized. It's given to you on a reference sheet. Basically what it does is it helps you solve for x. See how our previous problem just came out with 4 x's? This allows you to solve for x when you cannot factor, like how we did with AM. It's a really, really useful formula. It basically allows you to find the solutions to any equation that's quadratic set equal to 0. That's why it's called the quadratic formula. You can only do it when the highest power is 2. So only when you have this form can you do it. A trinomial with the highest power being 2. That's when you can use the quadratic formula to find x. Of course, you should always factor, try to factor first, but if you can't make it happen, then use the quadratic formula. So I'm going to do each of these separately. Also note that you want it in simple as a plus bi form, so we will talk about that in a second. I'm just going to write the equation on the side here. All over 2a. Okay, so first off, you need to know what a, b, and c are. In this case, a is 1, b is negative 6, and c is 3. It's always the number. So a is 1, b is negative 6, c is 3. It is not with the x. It's just the number in front, okay? And the constants. Alright, coefficients, that's the word I was looking for. Alrighty. So now I'm going to plug in negative b. Well, if you notice, this 6 is already negative, so it's going to be negative negative 6. Plus or minus the square root of b squared, so minus 6 squared, minus 4, a is 1, and c is 3. Make sure you're keeping this square root over everything. All over 2, what's a? 1. And then you're going to simplify. You're going to take this nice and slow. You're not going to rush anything going on here. So I'm going to do x equals negative negative 6 is positive 6, plus or minus the square root of, and then 2 times 1 is 2. Now here's the deal. Just type this into your calculator, the inside. There's no need to type the whole thing into your calculator. Just type the inside in. You'll get 24. The reason why you don't want to type the whole thing in is because you're going to get a decimal, and the reason why is that 24 is not a perfect square. You're going to then find the perfect square inside of 24, which is 4 and 6. This is why we learned radicals before this lesson, because you need to know how to simplify your radical. The square root of 4 becomes 2, and the 6 just tails on over 2. Now what you have to do is you have to write this as 2 pieces. You can't leave it all over 2. So what I call it is share the love. So you're going to share the denominator with both pieces. And then you'll get your answers. So x equals 3 plus or minus, these will cancel, square root of 6. Now I do want to note that there are 2 x values here. It would be 3 plus the square root of 6 and 3 minus the square root of 6. Now what does this really mean? This means that these x values are the values that would satisfy the equation, meaning that if you plugged in those values in for x separately, you would get 0, okay? And if this becomes 0, then the whole thing becomes 0, and you wouldn't have to worry about the other one. Okay, so that's really what's going on here. You are just finding the values of x that satisfy the equation to make it equal 0. Those are why they're called your roots, that's why they're called your zeros, etc. Now also notice we have two answers here, and that makes a lot of sense because the highest exponent of our quadratic is 2, meaning 2 solutions. So that's really important to notice as well. Okay, so now I got to do the other side of my equation. It's going to be 2x squared minus 4x plus 7 equals 0. Okay, so I'm going to have a equal to 2, b equal to negative 4, and c equal to 7. Okay, so I'm going to now plug in x equals negative negative b, so negative negative 4 in this case, because negative b is in the formula, and our 4 is negative to start. B squared. Now it's really important that you notice that I'm putting my parentheses around this b squared, and that's how you'll be typing it into your calculator. A is 2 and c is 7. If you do not put the parentheses around the negative, you will not get a positive. You should know that anything squared that's a negative comes a positive. And then 2 times 2, because 2 times a in the formula. X equals 4, because negative negative 4, over 4, square root of. Type this into your calculator using the parentheses, very, very important. You're going to end up getting negative 40. Now this is why we learn imaginary numbers first before this lesson. And if you notice, the reason being is because this has a negative inside the square root. And what does that mean? That means that there's a square root of negative 1 in here, and that means we have an I inside our answer, which means we have imaginary numbers. Okay. And then you're going to find the perfect square inside of 40. I believe it's 4 and 10. And then you're going to simplify that to a 2. And moving right along, you're going to have x equals 4 plus or minus, because there's two answers because it's squared, 2i squared root of 10 all over 4. And then you're going to share the love. And this is super important because if you notice in the problem at the beginning, it says that it needs the answer in simplest a plus bi form. If you do not break it up and divide like this, you will get the answer wrong, because a plus bi means that you need an a and a bi separate, not with the same denominator. The 4 over the 4 divides to 1, and 2 over 4 reduces to 1/2. So we get I radical 10 over 2. And those are my answers. You can leave it like that, or you can use the solution set, the squiggly brackets, plus I square root of 10 over 2, and then 1 minus I square root of 10 over 2. Just remember there are two answers because it's squared. And that's how you use the quadratic formula. The rest of this is pretty simple. It's pretty the same way. So please feel free to continue to pause and try questions as you go through the lesson, because if you're not pausing and trying them on your own, you're actually not seeing if you can do the problem. So like I said in the last video, you should really just try to pause these and attempt them on your own. Now, since we're using the quadratic formula, the most important thing is that you need to set it equal to 0. You can't have it doesn't work unless it's set equal to 0. Because really what's happening is you're finding your roots, your solutions, your zeros. It's where the parabola crosses the x-axis. So in this case, a is 1, b is negative 3, and c is negative 4. Always have the quadratic formula in the back of your mind. It's on the first page. So x equals negative negative b. In this case, it's double negatives because the b is negative. Plus or minus the square root. Now, I really shouldn't have done the quadratic formula. I'm just getting like into the motions of this. I just want to backtrack here, because if you realize, you can actually do AM here. And if you can do AM, you really want to avoid doing the quadratic formula. I just realized as I was doing the problem. If you notice AM, the factors of negative 4 are negative 4 and 1, or 1 and negative 4, or 2 and negative 2. But this is the pair I want because that adds to negative 3. And then you're done. So rule of thumb is don't just assume to use the quadratic formula. Try to use your other factoring techniques first, because then it should save yourself some work when you realize you can use them. Okay, set this equal to 0. Remember, x squared likes to be positive and equal to 0. Cancel. You're ending up with x squared minus 10x minus 25 equals 0. So basically the quadratic formula is a backup. It's the backup to AM and glasses. If you can't do AM and glasses, use the quadratic formula to find the x value. Now, 25 looks very promising because we know 25 breaks up into 5 times 5, and that does add to 10. But because it's a negative 25, one of these would have to be negative, and therefore adding these would not become negative 10, it would become 0. So AM is not a possibility. But when that happens, guess what? You're okay because you have the quadratic formula. Okay. So, x equals negative b, so it'll be negative 10, plus or minus the square root of b squared, negative 10 squared, minus 4a, and then c, all over 2a. Oops, that's a 1. Okay. X equals 10 plus or minus all over 2. Just type this into your calculator, just the inside. Do not type in the square root. Just type the inside in. It'll get you 200. And then you're going to reduce this. That gets you 10 square root of 2. Now the reason why you can't do AM is if you notice, we're starting to get radicals in our answers, which makes the answer irrational, and therefore you can't factor it with AM. So that's really what's happening. Plus or minus 10 square root of 2, all over 2. Share the love. Oops, what's happening here? Okay, 10 divided by 2 is 5, and 10 divided by 2 is another 5. And this is your answer. Okie dokie. Let's keep going. This is a little bit different, if I can find it. Yep. Set equal to 0, subtract the 3. And you get an x squared minus 8. And then you're going to notice, well, I can't factor this because there's not 3 terms. But since there's only one x value, you can actually do something nicer and just get x alone. I could have actually added the 5 over to begin with. Square root, you would get x equals plus or minus. Very important that you remember whenever you take a square root, you put plus or minus in. Break up 8 into 4 and 2. You're going to get 2 square root of 2. Boom. This should be a very familiar topic to you because, again, you did learn this in Algebra 1. Okay. This is a very large one. You can try to do glasses, but it won't work. And we're going to have to do quadratic formula. So A is 18, B is negative 24, and C is 87. And then, I keep zooming this out. And then you're going to do quadratic formula. Okay. So x equals negative b. So that would just be 24 because the negative that's there. Once you get comfortable with this, you will start to skip steps. B squared, that's negative 24 squared. Minus 4, A is 18, and C is 87. All over 2A, which is 18. X equals 24. 2 times 18 is 36. Plus or minus the square root of. Type that whole thing into your calculator, and you're going to get negative 5,688. That is quite large. That's a large number there. All right, and then you're going to put that into y equals, like negative 5,688, and divide it by x, and look at the table, and you'll find out that 36 and 158 are the pair you want. And then you're going to reduce that to 6, and 158 will stay because it's not perfect. And then you're going to end up getting 24 plus or minus this. Well, square root's gone now. It would just be 6 square root of 158. Again, you need to divide. Well, it's negative. So let's just not make mistakes here. Let's remember this is a negative on the inside. So what do we need? An I. Okay. 24 over 36 will reduce to 2/3. What you can do is type that into your calculator and then press math fraction, and it'll reduce it to you. 6 over 36, that's 1/6 because they go into 6. So that's your answer right here. The rest of the lesson's pretty much the same deal, besides number 5. So number 5, if you notice, has a squared. Now, of course, you can go ahead and box method that out, but remember the goal. The goal is to solve for x. So to solve for x, you would just want to get x alone. So I can square root either side, cancel this out. You're going to end up getting x plus 4 equals, remember we did a square root, so plus or minus the square root of 8, minus 4. So x equals negative 4 plus or minus the square root of 8. And then you have to reduce this to 4 and 2. You'll end up getting x equals negative 4 plus or minus square root of 4 is 2. So 2 square root of 2. Okay. This is equal to 0, so we're ready to go. You can try to check your factors of 9 that add to 6. And of course you're going to think, well, 3 and 3. But remember, it's negative 9, so it'd have to be different signs. And negative 3 and positive 3 would add to 0. So that would not be good. So A is 1, B is negative 6, and C is negative 9. So x equals negative B. So it's negative 6 in this case. Plus or minus the square root of B squared minus 4, A is 1 and C is negative 9, all over 2 times 1. X equals negative 6 is 6, all over 2, plus or minus the square root. Again, when you're doing this, just plug in the inside of your parentheses. Do not plug in the square root. Okay, you're going to simplify it after you're done plugging it in. And when you do get it, you're going to get 72. You're going to reduce this to 36 and 2, and you're going to remember the square root of 36 is 6. So you have 6 over 2, because remember we're going to share the love, 6 square root of 2 over 2. This is going to reduce to 3 plus or minus 3 square root of 2. Those are your x values. 2 more, I think. Yep. All right. Again, please pause and try this problem on your own. Okay, so hopefully you tried it. A, B, and C. Okay. Now, of course, I would try to do AC, because it's 4 times 2 is 8. And the factors of 8 are 8 and 1 and 4 and 2. And 8 and 1, if you subtract it, you get 7. But because it's not different signs, it's not going to subtract to 7. We want to have the same signs because it's a positive 8. So you can't do AC, so you have to do quadratic formula. X equals negative B, so negative 7 plus or minus the square root of B squared, 7 squared minus 4. A is 1. Oh no, A is 4 in this case. 4AC all over 2A. X equals negative 7 all over 8. Oops. Plus or minus, just type in the inside. Again, just the inside of the radical. And you're going to get 17. And you can share the love and try to simplify. So when you divide each piece by 8, you can see if they reduce. That doesn't reduce, and you cannot reduce this, so this will be your final answer. Or this, because they don't reduce. Okay, last one. A, B, C. X equals negative B, so negative 3 plus or minus the square root of B squared, so 3 squared minus 4. A is 2, C is 2, all over 2A. X equals negative 3 all over 4 plus or minus, and remember, just type in the inside of the radical, so 9 minus 4 times 2 is 8, 8 times 2 is 16, so 9 minus 16, negative 7, and then remember this needs to be reduced into negative 1 and 7, where the negative 1 is an I. It's an imaginary number. Always just zooming out randomly on me. Okay, negative 3 plus or minus I square root of 7 over 4. Now remember, you have to split it up when you have i's, otherwise it is not in simplest a plus bi form. Even when it doesn't reduce, you need to split it up. So like with the last problem, it wasn't an issue. You could keep it all over the same denominator because there wasn't an I. When there is an I, you absolutely need to do the share the love, like break it up, okay? Also, fun fact, when you graph the original, this guy up here, 2x squared plus 3x plus 2, it's going to float above the x-axis because your answer is imaginary. And that's this lesson, so I hope this helped you on lesson 22, quadratic equation, the quadratic formula, and I'll see you guys soon.